Hi everybody, welcome back to Master Engineer. In this tutorial, we have a simply supported beam with a length of 7 meters. The beam carries a point load of 45 kilonewton and a UDL of 15 kilonewton meter, as shown in the figure. Find the support reactions and draw bending moment diagram and shear force diagram. As usual, we draw the free body diagram first. Since the beam is simply supported, we will have only two reactions, one at point A, which is VA, and one at B, which is VB. Now we could see from the free body diagram that we have 45 kilonewton acting right at the middle of the beam and the 15 kilonewton of uniformly distributed load. So the total of all forces acting downward is 45 plus the 15 kilonewton multiplied by 7, which is 150 kilonewton. From this, we could simply say that each of the support reactions are equal 75 kilonewton. As the rule of equilibrium, the sum of all forces acting downward should equal the sum of all reaction forces. Since the total of all forces acting downward equal 150 kilonewton, we could see that VA is equal 75 kilonewton and VB equal 75 kilonewton also. But for the sake of learning, we carry on finding the reactions as normal. To find VB, we take moment about A. The sum of all moment at A equals 0. And negative VB multiplied by the total length, 7 meters, acting anti-clockwise. Positive UDL, 15 kilonewton, multiplied by the total length, 7 meters, multiplied by half of the 7, which is 3.5, acting clockwise. Positive 45 kilonewton, acting at the middle of the beam, which is 3.5 meters, also acting clockwise, equals 0. Rearrange the values. VB equal positive 75 kilonewton. We move on to find VA. The sum of all vertical forces equals 0. Negative 45 kilonewton acting downward, negative 15 kilonewton UDL multiplied by the total length, 7, which means every meter there will be 15 kilonewton acting on the beam. Positive VA acting upward, positive VB acting upward, equals 0. The total of all the negative values equal negative 150 plus VA plus the value of VB, which we found here, positive 75, equals 0. Rearrange the values. VA equal positive 75 kilonewton. To check the answers, take moment about B. The sum of all moment at B equals 0. We have positive VA acting clockwise, multiplied by the total length, 7 meters, negative 45 kilonewton, acting anti-clockwise, multiplied by half of the length, 3.5, negative UDL value, which is 15 kilonewton, acting at every 1 meter on the beam, which is 7 meters, multiplied by half of the 7 meters, 3.5, equals 0. If you plug all these values into the calculator, we could see that our answers are correct. We then move on to draw the shear force diagram and bending moment diagram. It's always easier to have the free body diagram in front of you while you're drawing the shear force diagram and bending moment diagram. And also drawing these lines will make life much easier. We start with the shear force diagram. The starting point is 0. Then we have 75 kilonewton, which is VA, acting upward. So it's a straight line to 75. Since we have 15 kilonewton UDL, that means every 1 meter, there will be 15 kilonewton acting on the beam. So every meter, we go down by 15 kilonewton. 75 minus 15 equals 60 kilonewton. Another straight line to 60. Then the next point is 45 kilonewton, which is 60 minus 15 kilonewton equal 45. And the next point, again, 45 minus 15 kilonewton of the UDL equal 30 kilonewton. The next point is a bit tricky. Since we have the point load of 45 kilonewton acting downward, from the 30 kilonewton, we only move by half a meter until we reach the 45 kilonewton. Therefore, 30 minus 15 kilonewton of the UDL multiplied by half of a meter, which is 0.5, equal 22.5. Then we reach the 45 kilonewton point load acting downward. So positive 22.5 minus 45 kilonewton, it will be a straight line all the way down to minus 22.5 kilonewton. As explained before, the next point, we move by half a meter again. So from the minus 22.5 minus the 15 kilonewton UDL acting at the other half of the distance, which is 0.5, equal minus 30 kilonewton. So the diagonal line from minus 22.5 goes to minus 30 kilonewton, which is about here. Next we have minus 30 kilonewton minus 15 kilonewton of the UDL acting at 1 meter equal minus 45 kilonewton. And the same again from minus 45 kilonewton minus 15 kilonewton of the UDL per meter equal minus 60 kilonewton. Again, minus 60 minus 15 kilonewton per meter equal minus 75 kilonewton. And finally, from the minus 75 kilonewton, we come across the reaction force from VB, which is positive 75 kilonewton. Therefore, it would be minus 75 kilonewton plus the 75 kilonewton of the reaction. It goes back all the way to 0. We could see all our points are correct. We started from 0 and we end up at 0. Next, we move on to the bending moment diagram. Same as before, we start from 0, but this time the unit is different, which is kilonewton meter. We could see from the shear force diagram, we have the next point from 0, it will be 67.5, because we have 75 plus 60 multiplied by the distance, which is 1 meter, multiplied by half of that 1 meter, because it's a UDL, equal 67.5, which is literally this area. Next, we have the 67.5 kilonewton meter plus 60 plus 45 multiplied by the distance, which is 1 meter, multiplied by 0.5 equal 120 kilonewton meter, which is about here. The next point will be 157.5, because we have the 120 plus 45 plus 30 multiplied by the distance multiplied by half of the distance equal 157.5 kilonewton meter. The next point is 157.5 plus 30 plus 22.5. Again, this time, distance is shorter, which is 0.5 multiplied by 0.5, because we are reaching here, just before where the 45 kilonewton acting downward, as previously mentioned, equal 170.625 kilonewton meter. Again, the next point will be 170.625 kilonewton meter plus minus 30 minus 22.5 multiplied by half of the distance multiplied by 0.5 equal 157.5. Another straight line from 170.625 to 157.5. The next point is 157.5 plus minus 30 minus 45, which is this area, multiplied by the total distance of this area, which is 1 meter, multiplied by half of that, equal 120 kilonewton meter. So from 157.5 to 120. Next, from the 120 plus minus 45 minus 60, multiplied by the distance 1 meter, multiplied by half of that, equal 67.5. From the 67.5 plus minus 60 minus 75, multiplied by the distance 1 meter, multiplied by half of it, equal 0 kilonewton. So from the 67.5, a straight line goes back to 0. Now we could see all our answers are correct. We started from 0, we end up at 0. We could also clearly see the 170.625 is the maximum bending moment. This is the end of this tutorial. Thanks for watching. Please remember to like, share, and subscribe to get all the latest videos.